39, this is in the interval 0 to 5. We have two graphs here, cosine 2x and sine 3x. They intersect 4 times. And A, B, C, D are going to be the x-coordinates of these points of intersection on that interval, all between 0 and 5. And the question says, which of the definite integrals has the greatest value? So, ultimately, if we look at the graphs of these two, see those intersection points. So let's go ahead and graph that. So we have cosine 2x. Type that one in first. And then sine 3x. And we're going to go from 0 to 5 in our window, which is already set up nicely, which is convenient. We don't need to go negative 10 to 10 here, that's probably too big, so say we just go negative 3 to 3. Closer look, the amplitudes are both 1, so it should be good. So keeping in mind that's the cosine curve that's first, and the sine curve being second. Alright, so ultimately the question then here and the choices that we have, we got from 0 to A of the first intersection point with the cosine 2x minus the sine 3x. And ultimately we want to compare that to our other values here. But let's talk about just that one for the first part here. If we look at the picture here, we're looking at this area right here, okay, that first part here. And you'll notice that the cosine part is on top, sine is on bottom. So if we did the integral with those two, with the cosine on top, sine on the bottom from 0 to A, we'd get something positive at least. True? So we'll say that that equals positive something. We don't actually have to calculate the answer right now if we don't want to. If we wanted to calculate all these answers, we'd have to go through, find all the intersection points, evaluate all the integrals. We might not need to do all that. If we just look at from A to B of sine 3x over cosine 2x dx, then that would be this region right here. And keeping in mind that the sine function is on top of the cosine function, so again, if we subtracted those two, we would get something positive on that interval as well. So that would also be positive. Okay. The next one we have from B to C of sine 3x minus cosine 2x dx. Oops, not that one. And ultimately, that would be in this next region, which would be this region here that we can see. And ultimately, the cosine x function question is which one's on top, which one's on the bottom. Well, the steeper one is the sine 3x here. And so, in any case, this is also going to be our positive area, because again, the sine 3x is this one, the cosine is this one. So therefore, that would be positive again, because they are in the right order in terms of subtracting and getting a positive. Alright, and then the other choice we have is from C to D of cosine 2x minus sine 3x dx. And if we look at the two areas that we have here that are between C and D, and then D and 5, if you will, you know, and again, I went through the whole process just to illustrate, but bottom line is if we looked at this immediately, wouldn't these two be probably the two candidates for the biggest area? So maybe we work from backwards to forwards first and rule one out or rule one in and see which one do we think is bigger. It'd be difficult to tell which one of these is bigger by just looking at it. They're clearly more area than the others though, so let's look and see if we look at the cosine minus the sine, and from C to D that would be this region right here. If we look at that, our cosine function is on top, the sine function is on the bottom, so this would also give us a positive area. And then finally from C to D, we don't even do D to 5, so I guess this is the only region in question. So again, you might have been able to rule out A, B, and C. Oops, they did it backwards, sorry. So sine 3x, and then cosine 2x dx. And ultimately, if we were to do that, we'd have the bottom function subtracting the top function, which ultimately would give us a what? Would give us a negative area, and therefore, which one's the only one that's a realistic option? Would be letter D. So like I said, if you looked at that immediately, you might have been able to just rule out those first three without even dealing with it, because you can see that this last region, the C to D region, is going to be definitely bigger than the others, whether they're positive or negative or otherwise. Okay. All right. Questions on number 39? What else? Les?
42.
Number 42, we have ddx of x to x cubed of sine t squared dt. And ultimately, and again, I forgot also this would be an AB problem here. Just area under curve, area between curves. And the next problem here, this is also an AB problem. Okay. This is ultimately that's the first part of the fundamental theorem, because we're doing the derivative of an integral function. So, whoops, first, think of two different things at once here. First part of the fundamental theorem of calculus. And so the issue we have though with the fundamental theorem is the fundamental theorem uses the a here as our lower limit here, and we have a variable lower limit, variable upper limit. So if you remember, the way we remedy that is the following. We rewrite this into two integrals. We write from 0 to the furthest part, which would be x cubed in this case, sine t squared dt, minus from 0 to x of sine t squared dt. Okay. So if we pick a particular starting point, ultimately that works because in general if we just want to find the area here and we're at x here and we're at x cubed here, and we want to find the shaded area, okay, we could start at some arbitrary starting point at the left that shows 0, and we could figure out the area from 0 to x cubed, and then we could figure out the 0 to x and take those two and subtract them, and we'd have the shaded area, wouldn't we? Okay. So keep in mind, we don't care about the areas here because all we're worried about is the derivative. Okay. So if we just want to find the derivative, now we can use the fundamental theorem. So ultimately the derivative here is again the integrand evaluated at the upper limit times the derivative of the upper limit. So that would be the derivative of the first part, and then the second part of course is just the integrand evaluated at the upper limit again, which there is no chain rule part to this because x is x and the derivative is 1. And so in simplifying, we'd write 3x squared sine of x to the 6th minus sine x squared. And if we look at the options there for number 42, we have looks like option C. Okay, any questions on that one? Okay, what else? Here. Kyle.
44.
Okay, on 44 we have a region in the first quadrant that is enclosed by the graphs of y equals x and y equals 2 sine x, and it's revolved around the x-axis, and we want to find the volume of the solid generated. So ultimately, again, we got first quadrant, we have y equals x, which looks as such, and then 2 sine x would just be sine with a 2 amplitude. So ultimately we would have basically something like that. So the region that we're looking at would be this region. Okay, well, roughly that'd be our shape, and we're going to revolve that around the x-axis, which of course is here. And if we revolve that around the x-axis, we do have a top and a bottom that are the same throughout the interval, so we could use a vertical slice. And if we use a vertical slice there, that's going to create what kind of shape? It's going to create a washer. And so if we want to find the an expression for the area or the volume of one of those washers, we know that washer method is going to be pi r squared h, and again the r here would be the 2 radii, outside radius minus inside radius, squared first of course. And so first issue though is what's that point right there? Because we need that upper limit. We know we can see that they're going to be 0. We could also set the whole thing up too besides that if we wanted to. The outside radius here is going to be the sine function, so 2 sine x squared minus x squared dx. So that would be our washer setup. But again, we need to find that intersection point. So again, instead of using algebra, let's go ahead and do a graphical way of finding that. So if we do 2 sine x and x and graph here, and as such, and if we use our intersection command, we get 1.895. Now, one thing that I would do for you, if I were you, in terms of rounding here, I would use all the decimal places available when I set up my integral and calculate. So ultimately that would do it for that part, and then from there it's just a matter of using the calculator to come up with an answer here. So if we use our integral command and we type in carefully the integrand here, 2 sine x all squared minus x squared comma x comma 0 comma 1.8954943, and we hit enter, we get that. And ultimately that needs to get multiplied by pi, so that's just the area part. So if we go times pi, get 6.678, which looks like letter D. And ultimately that would be an AB problem because of the fact that we can use washers, which is an AB topic. Alright. Questions on that one? What else? Sarah? 45, we have the tangent line to the graph of y equals 2 minus x at the point 1e intersects both coordinate axes. And the question is, what is the area of the triangle that's formed by this tangent line and the coordinate axes? So let's take a look at the picture here, if we can. We have here e to the 2 minus x. And looking at the point 1e, let's just try our same window that we've been using here and see what we see. So we'll want to make that a little higher on the y side than the y side here. Go 10 here and see if we see that intersection point. There it is. Alright, so with that, again, the question is at some point in this interval, in fact at the point 1e, which is approximately here, the tangent line there is going to make a, if we drew the tangent line here, it would make a triangle with the x and y axes. So ultimately, the issue here is if we have, you know, this curve, here's the point 1e, and if we drew the tangent line at that point, we would have a triangle. Alright, so bottom line is what would be useful here is if we could write the equation for that said line, then we could find the 2 intercepts, and in turn we'd be able to find the height and the base, wouldn't we? Okay. So let's see if we can do that. If we're going to write an equation for any line, we can use our point that we have given to us here to put in point slope form. And then the slope of the curve at that point is something we need to determine by using the derivative here. So if we know y equals e to the 2 minus x, and y prime then would be e to the 2 minus x times negative 1, because ultimately e's derivative is itself times the derivative of the argument here, of course, 2 minus x, derivative being negative 1. And so with this as our derivative, we want to know what is the derivative at 1. So if we do e to the 2 minus 1 times negative 1, we're going to get negative e as our derivative value at 1. So hence our slope. And so now we have an equation for that tangent line, y minus e equals negative e times x minus 1 quantity. So with that, like I said, the issue is can we find the intercepts of that line? Well, if we distribute here, and we do y equals, we'd have negative e to the, or negative ex, I should say, not to the x. So negative ex plus e, and we'd have another e that we'd add from the left-hand side. So with that, we'd have negative ex plus 2e. And we can see what the y-intercept is here, of course, it's 2e. So with that being the point 0, 2e in our picture. And then the other issue is what's the x-intercept? Well, if we let y equal 0, we have negative ex plus 2e. Negative 2e equals negative ex. If we divide, we'd get 2 equals x. And 2, 0 then would be our point in question. And now we should have enough ammunition to calculate the area of that triangle formed here. 2 being the base, 2e being the height, and ultimately we'd get 2e, which would be letter A. Okay, questions on that one? And ultimately, an AB problem, just application of derivatives. Questions on that one? Others?
What's the equation for number 38? The standard equation.
For 38,
Yes.
the length of the path for parametric equations, if you it comes from our curve length that we did in the AB part. We have the square root of dy dt. I think trying to remember. I think the book puts dx dt first. So I don't think it doesn't really matter, obviously, but. Oops. All right. So ultimately, that would be our curve length in parametric form. Pretty sure it's been a month or so. I would look it up to be sure, but I think pretty sure that's what it is. Other questions?